Hello. Today we're going to talk about pattern block fractions. And we're going to start with our math message today, which states if the hexagon pattern block is the whole, what fractions are represented by the trapezoid, the rhombus, and the triangle? So remember, our whole is your hexagon there in the center, the yellow shape, the hexagon. So first of all, let's look at the trapezoid. Which one of those is the trapezoid? It would be the purple one. And if we asked what fraction is represented by the trapezoid, we can see that if I move this trapezoid over here, you'll have to ignore my white section there of the picture, that is about half of the hexagon. So a trapezoid would be 1/2. What about the rhombus? That would be our green shape right here. And again, you're going to have to pretend that that white part is not there. But if we put this on our hexagon, and it's not exactly the same exact shape, or size, I mean, we could see that as I look at this shape, I can turn it to fit on there just a little bit better. I can actually fit 3 of those on there. They kind of go in different shapes, or spaces, I mean. It actually looks like a 3-dimensional square when we do that, and you'll see how we do it in class. But basically, that particular shape, that rhombus, would be 1/3 of the hexagon. What about our triangle? I've got a triangle here. I'm going to set it here in the center. And you can kind of see that if I drew a line in the center of this, and actually my triangle were exactly the right size, I could fit 6 triangles on that hexagon. So that one triangle would be 1/6 of that hexagon. So I'm going to take those off of there. So the triangle itself would be 1/6. Our rhombus was 1/3. And our trapezoid was 1/2. So in this lesson, we're going to use pattern blocks to model fraction and mixed number addition and subtraction problems. So as you can see, I kind of have a little bit of a mess here, but if I were going to do the problem that says 2/6 plus 1/6, now which of those pattern blocks were 6? Those would have been the triangles, correct? So if I had 2/6 plus 1/6, so basically this is what's going to happen, right? My answer would be 3/6 when I add those together. Okay, I'm showing you with pictures and pattern blocks because sometimes it makes it a little bit easier to understand. Okay, so that was our 2/6 plus 1/6. I'm going to move that equation off to the side here. We're going to pull up another one here. What if I had 1/3 plus 1/2? 1/3 plus 1/2. So I'm not going to be using my triangles for this one. I need my 1/3, which would be this, and 1/2. Now how would I add those together? They're not the same shapes. Can I get, would 2 of my rhombuses equal a trapezoid? Not really. Could I trade these for triangles? Yes. So if I thought about my rhombus there, that would actually make 2 triangles, right? And my trapezoid would actually make 3 triangles. So when I add those together, I would have 5 triangles, or 5/6, because we changed it to triangles, so my denominator would be 6, since it takes 6 triangles to make a whole hexagon. Okay, so what did I do in that instance? I traded some of my triangles to form part of that trapezoid and that rhombus. Okay, so we're going to move this one off to the side. We've done that one. Let's take a look at this one. If I have 2/3 plus 1/6, so basically I'm looking at 2 of these and 1 triangle. See if I can get an upside down one here. And if that were bigger, we could see that I would need 1 more triangle to make a whole hexagon in that instance. So again, if I divide this up as it would be all triangles, this would be 1, 2, 3, 4, 5 triangles. So my answer to that problem would be 5/6. Okay, so what I've been doing here is taking my pattern blocks and trading them so that I have the same kinds of pattern blocks. And the reason we do that is it makes it a little bit easier to add and subtract when we have the same unit, so to speak. Okay, so we're going to move this one down. We've done that one. Let's take a look at this one. If we have 1/3 plus 1/3, this one's a little bit easier because they're the same color, right? Same color, same shape. So my answer is pretty simple, would be 2/3. And one of the things to remember about adding and subtracting fractions is if I have a denominator of 3 here and a denominator of 3, basically what I did was I added the 1 and the 1, which equals 2, and we just brought that denominator over. So when we have a denominator that is the same, that carries over to our answer in most cases, and we can just put that as our denominator and add our numerators. All right, so let's take a look at our next problem. We're going to move that down here. So now if I have 1/6 plus 3/6, now notice I have the same denominator in this equation. So if you remember what I just told you, what would my answer be? Would I need to use my pattern box? No, not necessarily, but if you'd like to see it, I can show you what's going to happen. So we have 1/6 plus 3/6. So here's 1, 2, 3. So we almost have a full hexagon, but not quite. And my answer would be 4/6. Okay. Again, I could have added the 1 plus the 3 on the numerators part there and then brought over my denominator. Alright, so now we're going to try some mixed numbers. If I have 2 and 4/6, that means that I have 2 whole hexagons and 4 sixths, and I have another whole hexagon and 2/3. So first of all, we're just going to add our whole numbers. So our 2 plus our 1 is going to give us 3. Okay, and then we have our 4 sixths, which I just happen to still have there with my triangles. And we're going to add 2/3 to that. So if I add 2/3 to that, that's basically going to be 2 more triangles. So that gives me a whole, doesn't it? So actually, my answer is not going to be 3. The answer to this problem would be the whole number 4, because this became a whole when we put in that other rhombus there. Okay? So for that particular problem, we actually got 4 as our answer. I'll move all that down there. Okay, let's bring up another equation. We have 2 1/2, so that means we have 2 hexagons and a half. So I'm going to move this over. Well, actually, we're going to have 3 sixths in the next part, so I'm going to move one of those. We've got a half. Oh, wait, looky there. It's a little large right now. I can resize it, but you can see that that's going to make a whole. So 1/2 and 3 sixths are going to equal a whole. And 2 plus 1, our whole numbers here, the 2 and the 1 equal 3. And then don't forget our fractions equal another whole. So our answer to this problem would be 4. Okay, we're going to move that. Okay, let's say that we have 2 1/3. So we're going to get this out of the way. And we're going to move these over. And so basically we're adding a third and a third. And I kind of resized that a minute ago, so it's not quite the right size there. Okay, so there's our third and our third. We're going to add the 2 whole numbers, 2 and 3. That gives us 5 as our whole number and 2/3 as our fraction. Because again, we have the same denominator, so if we add the numerators and just bring our denominator over, our answer would be 5 2/3 for that particular problem. I've got quite the mess down there, don't I? All right, so let's get to this one. 1 1/2 plus 1/2. So I'm going to scoot these out of the way. We've got a half, and we've got a half. Well, a half and a half equal a whole, correct? So our answer to that problem is going to be 2, because we had 1 whole to start with and 2 halves that made another whole. So basically we had a whole plus a whole. Okay, if we have 2 1/3, so here's our 1/3, and we're going to add another third to that. And we have the whole number 2. So what's our answer going to be? 2 2/3. Okay? Alright, so this was adding fractions and mixed numbers using pattern blocks. Now we're going to take a look at some strategies for subtracting fractions. And I've got 3 problems here to get started, and I've kind of modeled them with the pattern blocks already. But our first problem is 5/6 minus 2/3. So I've got the 5, 6 modeled with my orange triangles there. And I have the 2/3 with the green rhombuses. And basically what we're going to do, we're subtracting that 2/3. So I'm going to kind of show you how I'm going to do that. I made the 5, 6, and whoops, I need to grab my wrong tool there. I'm going to move this over here, and I'm going to cover up 2 of those triangles because that's what that rhombus is equal to, right? So I'm taking that away, and you can't, that kind of went under there, but that's going to take that triangle away as well. It won't go under there, but pretend it's under there. So basically what we have left is one triangle after we cover those up and take them away. So our answer to that problem is going to be 1/6. Okay, so let's take a look at the next problem. We have a mixed number here, 2 and 5/6 minus 1 and 1/3. So as you can see, I have 2 hexagons for my 2, and I have my 5 triangles for my 5, 6, and then I have another hexagon and a rhombus to represent my 1 and 1/3. So basically, we are going to, again, cover these up, and because I've got yellow over yellow, you're not going to really notice that that's gone, but pretend that you do. So one of those hexagons is now gone. We've subtracted that away, and I'm going to move, again, this doesn't want to cover up my triangles, but that's going to take 2 triangles away. So I have 3 triangles left and 1 hexagon. So that means that my answer is going to be 1 whole and 3 triangles out of 6, which would make a whole, or 3/6 for that particular problem. So 2 and 5/6 minus 1 and 1/3 is equal to 1 and 3/6. Let's take a look at our problem at the bottom. We have 5/6 minus 2/3. Again, I've modeled the 5/6 with the 5 triangles. I have my 2 rhombuses there representing my 2/3. I am going to move this over here to subtract that part. And I'm going to move this one over to subtract this part, which means I have one of those triangles left. And this is the same problem that we did at the beginning, isn't it? So this one's going to equal 1/6. Just checking to see if you're paying attention. No, actually, I put the same problem on there twice and didn't mean to, but that's okay. All right. We've got some different strategies that we've been using to add and subtract fractions using pattern blocks where we cover them up or we trade them. And this is an example where we're going to trade some pattern blocks. I've got 5/6 minus 2/3 again, and I know this is the same problem, but basically I'm showing you that 2 of those triangles represent 1 rhombus on each of those sides. So if I'm going to subtract 2/3, that means I'm going to have 1/6 left, because the only thing that I have left is this one little triangle right there after I've used that one and that one for this, and I've used this one and this one for this. Okay, now if we go down to the bottom, we have 1 1/2 minus 1/6. So my 1 1/2 would be my hexagon and my trapezoid. And we're going to take away 1/6. Now I've got 3 triangles there because I'm just showing you that it takes 3 triangles to make a trapezoid. So we're going to actually trade. Okay? So we're going to trade this trapezoid for the 3 triangles. So I am going to give my trapezoid to someone else, and I'm going to take these 3 triangles in a trade. Now I'm able to subtract 1/6, which means one of those is going to go bye-bye because I've subtracted it. So my answer to this problem, I'm still going to have my whole hexagon. And then I'm going to have 2/6. So my answer would be 1 and 2/6. So to summarize what we have talked about today, we have used pattern blocks to add and subtract fractions. We've looked at different strategies for using pattern blocks, one where I take away the blocks and one where I trade blocks or cover them up, whichever way you want to refer to that. And hopefully once you start to do some of this in class, it will start to make a lot more sense because you will actually have the pattern blocks in front of you. You'll be able to manipulate and move them around so that you can actually see what's happening yourself. Thank you for watching.